Hello, ladies and gentlemen. Welcome to Aviation Crash Course 101. We're going to cover the basics of flight in less than 5 minutes. There are four forces that are applied to an aircraft, namely weight, lift, drag, parasite and induced, and thrust. Let's cover the most basic of the four forces applied to airplanes. That is weight. Weight acts downwards towards the ground. The equation for weight is equal to mass times acceleration, kilograms times meters per second squared. If you've ever lifted something heavy in your life, you know what weight is. Now let's talk about lift. Lift is made up of a few variables. Number one, we have the coefficient of lift. Second, we have the surface area of the wing. And Q, which is the third, is the dynamic pressure. Dynamic pressure is the air smacking the front of the wing. If the Q increases, meaning if you go faster, the lift increases. If the surface area of your wing increases, your lift also increases. And lastly, if your coefficient of lift increases, meaning your angle of attack or your wing shape, your lift increases. This also works vice versa. If the aircraft begins to slow down, your lift will decrease. If you have less surface area on the wing, your lift will also decrease. And if your CL decreases, meaning if your angle of attack decreases, your lift will decrease. Now let's talk about drag. Drag works in a rearward direction of the aircraft. There are generally two big forms of drag, one being parasitic drag, the other being induced drag. Parasitic drag, put simply, is just air friction. If you've ever stuck your head out of your car driving at 120 miles an hour, you'll feel what parasitic drag is. The thing you have to know about parasitic drag is that it's exponential. It gets worse the faster you go. At 240 knots, I would have 4 times the amount of drag as compared to 120 knots, not twice as much. Now on to induced drag. I believe that induced drag is one of the most misunderstood basic aviation concepts in the industry. I do want to go into more detail regarding induced drag, but this is Crash Course 101, and I do have to keep it under 5 minutes. I believe the audience needs to have a general understanding of lift, angle of attack, relative wind, aspect ratios, infinite and finite wings, ground effect, wing vortexes, and also wing airflow patterns. But for this crash course, I'm going to simple it down as accurately as I possibly can. Induced drag is a phenomenon where the lift vectors tilt aftwards, and this occurs predominantly towards the wing tips. The pressure differential from on top of and below the wing causes a localized disturbance towards the tip of the wing that changes the airflow pattern, and that change in airflow pattern is what causes the lift vector, or that arrow that aims upwards, to actually tilt backwards. If it isn't obvious from the graph, induced drag is the inverse of parasitic drag, so it tends to be greater at lower velocities, and as you increase velocity, it tends to decrease. Now we're finally at the last topic of this lesson, thrust. Modern-day propulsion still depends heavily on airfoils, so to put simply, they depend on propellers or they depend on fans that are typical for commercial jets. Some people might be wondering why I elected to recycle some of my previous slides. It's because props and fans have a very similar operating principle to wings, and I wanted to show that here to you. Is it better now? This orientation is what typical people think of when they think of thrust. I'm going to finish drawing the propeller nose cap so people could see that they're looking at a profile view of a propeller blade. Just like lift, there is an action and reaction with propeller blades. The action would be the force of the airflow being accelerated, and the reaction would be the propeller and the body of the aircraft being propelled forward. The rotation of the propeller is what causes the airflow to strike the propeller blade. Remember from earlier, increase in dynamic pressure, or Q, increases lift. So in this case, increase in Q increases thrust. Thank you for watching Crash Course 101. If you liked the video, give it a thumbs up or subscribe, and I'll see you next time. Bye-bye.